Hello, how are you? Welcome to another episode of the podcast.
Good afternoon. These are your hosts, Yawar and Nabil, or as some people might call us, Nabil and Yawar. And we are bringing you another exciting episode of our podcast. Nabil, you want to get
So
us?
tell me, Yawar, what do you do?
What do I do? Yeah. I actually, try not to talk too much or go into too great details about what I do because the risk of doing that is basically boring people to death.
Yeah,
And not in the sense of Elon Musk's boring company, but rather like actually you will fall asleep. Um, yeah, but basically I'm a software developer
a
and
software
I
developer.
work on computers. Yeah.
I thought it would be interesting. The world is completely going digital. Like so many things have gone digital. And I think, 20 years ago, being a software developer was something that was a very small percentage of the population was doing. But now we're at a stage where even grandpas are trying to pick up some kind of coding because they need it. You know, I thought it would be interesting for us to like talk through what's happening in the programming field because we love talking about tech, but at the baseline is the programming field. And since you are a software developer, you would know more about it than I do. So I'd love to get your take on like what's happening. Where are we?
Yeah, absolutely. And I think that it's important to an extent to know a little bit of the history as well to understand where we are and where we're
Yeah.
going. Because a lot of things are happening. You often hear about software issues in the news. Certainly, you hear about security issues. You hear about data breaches.
Yeah.
So you might be wondering, what is all this? What is like? What's the situation and where are things headed? So a little bit of history. Obviously, computers really kicked off around the time of the Second World War. I'm not going to go into excruciating depths about that, but
Yeah.
basically, major funding from the U.S. and other governments caused what we would say is a Cambrian explosion in innovation in computers and software, hardware, all of these things combined. Now we find ourselves in a situation where we have the internet. So much of our daily lives are driven by software and helped by software, and in a lot of cases hindered by software. So, what is the current state of the world of software? As somebody, Mark Andreessen, you might have heard of him, famous entrepreneur and early internet pioneer, famously said is he wrote an article saying that software is eating the world.
Hmm.
Now, a lot of things I disagree with about with Mark Andreessen, but in this I think he's right. Software is eating the world. Everything everywhere you go, you have software. You have software in your car now, in your fridge, in your washing machine. Pretty soon, in your obviously in all of our consumer computing and entertainment devices.
I
Everywhere
think
you go, it's software.
And I think one of the interesting things in there, and this is pretty much my 20s was spent seeing this happen, is also the shift from software that is on just your personal computer to software now that is cloud connected and interconnected with the internet. So everything is now, even if it's just on your computer, it will often get updates. It will go connect to find more information. So I think there's also an element of like the scope of things in digitization has suddenly shifted to a very individual basis to a global or a you follow what I'm saying, like the cloud architecture has changed the scope of how and what we do with software as well.
Yeah, it's funny. In a couple different ways, if you look at it in a sense, it's interesting how cyclical this industry is, and software in general is, because back in the old days, we had mainframe systems where you had time sharing systems. Famously, Bill Gates was when he was a kid, he was so obsessed with computers, but the only way he could get access to them was by going to uh, this like giant shared computer system and trying to get a small slice of time where he could run his programs on it, and he would teach himself that way when he was a kid. So we had these giant communal shared computers that we would access. And then we had the personal computer revolution. Bill Gates himself, ironically, he's famous for saying that he wants to put a computer on every desk and in every home. And he did that essentially. Now we have computers everywhere. And so the personal computer revolution kicked off. Everybody got their own computer, great. But now, after the internet took off, we are again now in the age of the cloud, as you call it, Nabil, which is um, if you look at what the cloud actually is, it's just a computer running on running in somebody else's data center. So really, we are back to the old days of mainframe systems that you connect to. Only you're connecting it from your own computer. So we have a kind of a hybrid model now with the cloud. So you have your own device, you connect to somebody else's device.
So let's talk about it from a let's say I want to get into computer science perspective, right? So what you've just described to me is that it's a complicated system, right?
Absolutely.
There's a lot of different areas that are involved in this. Can you just like talk me through the layers that are there, like start from like the hardware piece of it, and we don't need to go in depth in any one of the layers, but just a sense of like how do these things stack up on top of each other to help to create the services that are there.
Yeah, you're right. There's a ton of complexity, and it's all built in the way by piling on layers on each other. So you have layers of hardware and software interleaved, and you find software in surprising places. For example, let's talk about your standard, cloud data center, for example. When you check your email, when you check your shopping cart, or your, delivery order, things like that, you are essentially connecting to software that's apps that are running in the cloud. And the cloud is, as like I said, these really maintained by these really dedicated teams who are set up these data centers, giant buildings full of computers, where some of their biggest concerns are just getting energy into these buildings and the computer systems, and making sure that they have enough supply of cooling energy, coolant, so that the computers don't overheat, because they're running all the time. They have to be running every single hour, minute, and second. And they require incredible amounts of maintenance. You have to switch out hardware.
You should know that I've done data center design as well. I've designed a tier 4 data
Nabil,
center.
what haven't you done? You have done so many things.
It was a little project, but I've done this as well, and I know what goes into like, so
those are the building blocks of the cloud.
Yeah, if you need a tier 4 data center is a building block. You need a 99.9
Availability.
availability, and you need to have a redundant connection.
To put that in perspective, 99.9% of availability is maybe a couple hours, maybe less, maybe an hour, about an hour, less than an hour of downtime per year.
And that means you need to have the physical redundancy, you need to have the energy redundancy, so multiple sources of power coming in, and then you also need to have the communication redundancy, so you can't have just one phone connection going out. We had a satellite radio connection to the main data center as well, for the design that we did, as a redundancy. So like there's a lot of like hardware that actually goes, and infrastructure that goes in terms of maintaining that, to ensure that at the end of the day, you as a customer, when you see your phone's not working or something's not working,
some app is not working. Yes.
Yeah, some app is not working. That's the part that we're talking about. That's what gets affected. 99% uptime.
Yeah, it's incredible. Before, in the olden days of the web, what people would have to do is they would have to maintain their own servers. You would have to buy your own computer server. You would have to buy your own rack. Back in the olden days, I was talking about the good old days. Like I was there. I wasn't actually old enough to do that kind of stuff. But there were stories of people who've done that. Maybe you have, Nabil, given your extensive experience. But anyway, what happened after somebody came up with this idea, and by somebody I mean Amazon Cloud Services, Amazon Web Services, and they made a pile of money by doing this. They said that, well, basically, what if every for the Black Friday, every year for Black Friday, we have this intense rush of sales and traffic to our site, and we have to plan our capacity and build it up and build it up, and we have to have huge amounts of servers just to be able to handle this Black Friday sale event. So make sure we don't go down when people are trying to shop, do their shopping. But the rest of the year, we have almost no traffic, and all of the server capacity is lying unused. So why are we paying or we are losing tons and tons of money maintaining all of this capacity when almost all of it is unused almost throughout the year? So why don't we rent out this capacity to other people who need it? It was a crazy idea when when they initially thought of it, and they had to fight for it, from what I understand. But after they launched Amazon Web Services, one of the first offerings was just S3, which is simple storage service, just like putting files in the cloud. Store your files in the cloud, like pictures, videos, any files, small to large. Well, after they launched it, it kicked off another Cambrian explosion. This is one of my favorite phrases, by the way, Cambrian explosion of innovation in startups, which suddenly, all of a sudden, they didn't have to worry about maintaining their own hardware for their apps, and all of a sudden they could just rent out the cloud capacity, compute, storage, database from Amazon or whoever, and set up their apps.
So now we've got one field which is okay, there's an environment that needs to be created. As if I'm telling somebody, a new person who's joining the software field, I can tell him, you can go into the development of this environment, that's cloud infrastructure. Now, there's things that are done on the cloud. And can you talk me through what's the back end stuff that's happening, and then we'll walk to the front end. And then what I would also like to talk through is some of the languages of the back end and front end, as you and some of the capabilities of those languages in there.
Yeah, absolutely. So, what goes on behind the scenes of an app that you might want to use? Let's say you like one of these apps, like let's say Facebook, right? What goes on behind the scenes? Well, Facebook is maybe a little bit of a bad example because they're at such a huge scale that they have to essentially maintain their own cloud. They can't use somebody else's cloud because they have such gigantic scale. But architecturally, it's not all that different from what many other startups are doing, even at a tiny scale. What Facebook or all of these apps do is they have what's called tiers. They have a multi-tiered structure of their applications, and the tiers are separated into front end and back end. Front end, back end, storage, database, these kinds of like niches which are talking to each other to build up your entire application. The front end piece is what you see. The back end piece is what you don't see, which is the piece that's on the cloud on somebody else's server, somebody else's computer. What are these back end pieces? These are continuously running pieces of software which have to deal with requests coming in from front ends, which is apps on people's phones.
So let's walk through an example. Let's say I'm ordering something on my phone using an app for a restaurant.
Ordering a delivery on your phone app. Yeah, perfect. So yeah, what happens is that you have your app on your phone, you place the order.
So that's the whole placement of the order, etc. is actually happening on the front end side of things where I'm interacting. And so there's certain languages that are specifically made for front end interaction. So the ones that I know about is HTML5 and JavaScript. And the way I think about HTML is it's very snapshotty, right? And being snapshotty means that it gives you a page, and that page is not very dynamic, which for some things it's very good for, such as if you want to store small pieces of information or display small pieces of information which don't need to move about. Let's say you're doing a very official kind of thing like the government of Canada does. It might be very useful for something like that and make it look authoritative, etc., etc. Whereas JavaScript is more dynamic in nature, as I understand it, and it's great for like fun functionality and things where you press something and things need to change. less authoritative, more interactive and immersive kind of experiences. Would you say that that's the case?
Roughly, yes. To understand HTML and JavaScript, in a valuable and a deep way, I would recommend looking at the history of these languages and why they were created. So HTML, Hypertext Markup Language, was created at this Swiss research facility called CERN by this guy called Tim Berners-Lee. And it was based off of earlier technologies which had similar structure of the files. You would put in certain commands in the files, in the HTML files. But what he did was and what he was trying to do is like, you have to look at what his intention was with HTML originally. It was a very simple language, uh, hypertext markup language. It's all in the description of that acronym, which is to say that he was looking to publish his articles online on the internet for other scientists to easily access. And he was looking to mark up the articles in certain ways to make them easier to read. So, for example, he would want to bold certain parts, he would want to italicize, he would want to have headers, much like you do in a Word document nowadays. But the most important innovation that he created was to have something called a hyperlink in HTML. That's the single biggest innovation of HTML. You have a document, and you have a piece of that document, some text inside the document, a few lines, maybe a paragraph, which is clickable. And when you click on it, it takes you to some other document. And this was again, I'm going to use the word Cambrian explosion again, the phrase Cambrian explosion, because I consider that important. Because before, when you wanted to cite, academically cite, do a citation, you would put a footnote at the end of your paper or document or whatever. But now you would put it directly in your same paragraph or line where you're talking about it, and you would just hyperlink it. And the user could immediately jump to it and see exactly what you're talking about. And then they would come back and resume reading. Anyway, so hyperlinking was the central concept of HTML. But the rest of it was just a simple markup language. Cool. You got your bold, you got your blinking text, you got your italics, headings, all that stuff is great. Now, what happened in a few years was that people suddenly started realizing, hey, we can actually put a lot of stuff on the web online, and people can easily read all these documents. But now people want to do more complicated things. They don't want to just read, they want to consume, they want to interact. So what if I put on an online store and allow people to order from my website? And I can drop ship them whatever I'm selling, right? Like I'm a merchant. So if you want to do that, in the early days of HTML, you can't do that. So you just put your email address on your webpage and you say, hey, if you want to order something, just email me here and I'll ship it to you. And you send me the payment, send me a check, whatever. And people quickly figured out, well, what if we made this better? And so HTML got some capabilities for sending commands from the page, not just like browsing pages and clicking and going to new pages, but now actually you can send a command from a page to the server which is hosting the page. Like, for example, place an order. Great. Another sea change, another revolution. You can now send commands back to that server, to the computer which sent you the page. You can place orders, you can do shopping, blah, 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 all that stuff. Great. Now, where does JavaScript fit in here? Well, people said that, okay, now we can do interactivity, but it feels still a little bit too kind of like not a great experience, because you have to click on this thing, you have to submit this form, you have to do an order or whatever, and then it reloads your whole page, you can't. You have to keep talking to the server again and again for every piece of interaction that you want to do. What if? But nowadays people, thanks to Bill Gates and the PC revolution, they have these powerful computers. Why can't we take advantage of these computers that the people already have? What if we could run some code on their computers instead of having to call back to our server and run code on our server all the time. We would save so much traffic and server expense, server costs from dealing with all of these requests. So let's ship a little bit of code to the user's computer and let it run on their computer and do some cool stuff on their computer. Well, now you have something like JavaScript, and JavaScript was created by this guy called Brendan Eich at Netscape, right? In like in a legendary feat of coding of like 10 or 11 days. And they told him at the time Java was the craze, right? Java was everywhere. It was in phones, it was in devices, it was in TiVo, whatever. All of these embedded. Java was the big in web and embedded systems. So everybody was like, we want to be like Java. Let's, if we can't have Java, we have to make something that looks like Java so people are attracted to our stuff. So they told Brendan Eich, well, listen, we know that we told you to do, to make this language, and we know that you made this really cool language that is based on theory and whatnot, but we want to call it JavaScript and we want you to make it look like Java. So he had to basically then go in and change it to look like Java, and so that it would appeal to mass audiences. And so that was the origin of JavaScript and running code on your users' computers.
So here's what I'm understanding. So there's a cloud where servers live and they do something for the back end. Then they communicate to the front end, which is on your computer or your device, and there are some interactions that happen over here as well. Now we've talked about the cloud and we've talked about the front end, what happens on the front end. So we place the order itself, right? The selection of the item is happening on the front end on my phone.
Add to cart? Yeah, for example,
Add to
when
cart.
you want to add an item to your cart, you no longer have to send a command to the back end.
Yes.
You can just do it on your own computer.
Yes, and so I've done that. Now that I have done that, and what the difference between what HTML and JavaScript is, in essence, is how often do you communicate with the backend to confirm things or update things, because JavaScript stores it on your device itself.
JavaScript runs code on your own device.
Yes. So all your menu and your prices are stored on the device. That's why you don't have to double check. You're able to add everything. And now I press place order. Now a command is going sent by JavaScript to the backend. What's happening on the backend? Now explain to me what's the backend, what languages are used over there, because we've done a bit of cloud, we've done a bit of front end. I want to cover the backend, and then we're going to talk about the interconnections of all of this.
Yeah, absolutely. So the front end, you place the order, you click the button, the order goes through to the backend server on the cloud or wherever it is. And now what happens here? What's going on? So on the backend, when we talk about the web and web technology, you have to realize that it's conceptually, you have to think of it as very similar to placing a telephone call. So you pick up the phone, you dial a number, and then you hit call, and it places the call, and the sounds or the electronic signals.
There's a handshake that happens.
There's a handshake that happens, and there's signals that go back and forth.
Yeah, there's a confirmation of like, hey, are you the person I'm supposed to be talking to?
Yeah, exactly. Right? If we're talking about person-to-person communication, what do you say? You say hi, and then the other person says hi, hello, and then you say, are you so and so? And then the other person says, yes, I'm so and so. And then I say like, okay, I'm going to send you an order. Please write it down and place it for me. And then you say, yeah, I'm gonna do that. So you have to realize that what's happening on the communication between front end and back end systems actually looks a lot like that, just in a digital form. It's a lot like placing a phone call and placing an order, but just digitized.
And so now, if I'm at the back end, I'm the guy receiving the call. What would I do once I get the call? And
yes, and the analogy actually continues very nicely there as well. So traditionally, if you're on the phone call and you just somebody just gave you an order, what are you going to do? You're going to write it down in your order book. Okay, so you're going to write it down in your order book, and then After you hang up, you're going to go into your warehouse and kick off the process of packaging up the inventory and shipping it off.
Or you're going to delegate it.
You're going to tell somebody to do it for you.
Yeah.
So the backend systems not work very much like this, but just in a digitized way. So for example, you have a system in the backend in the cloud or the server, which is writing down the order, or we call it saving or committing the order into the database. Nowadays, we have databases which can track many different kinds of data and information, and order books are one of them. So orders. And so you save this information in the database, and then you kick off the process of somebody fulfilling the order, or some other backend system comes online, maybe instantly or maybe in a few hours. Some people like to run their jobs periodically, maybe once a day, maybe once every few hours.
And in this case, because it's a restaurant, we're assuming it does it within the 5 minute scope because it's a restaurant.
Yes, I forgot we were talking about specifically the restaurant case. Yes, so in the restaurant case, right? So you write down the order, you send it to the back of house, to the kitchen. They're going to prepare it, and
you also confirm it with the client that hey, the order is on the way.
Yes, you might in the olden days you might give them another call and tell them, hey, we've just sent somebody over. They should be at your place in about let's say 20 minutes.
So I heard 4 or 5 different elements in there. I'm going to ask you to talk through some of the languages of these elements. One was security.
Yeah.
One was the delegation and processing. One was the storage aspect of it, and one was the communication aspect of it beyond the security, just the back and forth communication. Some of these are handled, as I understand it, by different types of environments like APIs, and some of them are handled by languages like Python. So just a bit of understanding of like what's happening over there, a bit of like a map for that particular piece, if you could, or in terms of languages.
Yeah, so in the back end, there are many systems which talk to each other. If we're talking about a restaurant system, for example, the system that just took your order, it's going to put it in the database, it's going to do a bunch of things, and then there are other systems might kick in and do some other things. Now, when I talk about systems, I'm talking about really software applications and services which are running on the database on the cloud server in a very similar way to on which your apps run on your phone or your computer devices. In a very similar way, there are these specialized softwares which run on cloud servers and which do all this order processing system. For in this case the restaurant food ordering system, and these applications, these services are where do they come from? Obviously they're not magic. What happens is that people write these software systems, and they create them, and then they deploy them onto these server hosts on the cloud or wherever they are. But the process of deployment, there are many different ways to do it, but essentially what happens is that when it gets deployed, it ends up on the server host in a form that it can be executed by the machine. And so it keeps running on the machine, and it keeps waiting for orders to come in. It keeps waiting for events to happen. Many of these systems nowadays are what you would call event-driven. They just are running continuously and waiting for events and orders to come in and reacting to the events and orders and such and so on and so forth. And so they trigger other events and reaction, and other systems pick up those events and they react to those. So it's very much we are living in an event-driven asynchronous world.
And so this basically becomes what APIs tend to do, which is it's API stands for application
programming interface. Yeah.
Programming interface. And sorry, I tend to forget. That's just me. I have fish memory sometimes. So API stands for application programming interfaces, and a lot of the listening and the communication is done via APIs as push and post. So that's one element of it. then there is also, of course, the actual transactional, 2 plus 2, add these together or multiply these, or so that can be done by the coding language itself, like Python or Scala, or you can have functions for that. And then there's the data storage element of it as well, which you just mentioned. um, I'm gonna flip this question around, because I'm trying to get at some things, take out some things in terms of directionality. If somebody's starting in this field, where they can be going. So, what would be the top 5 languages in your opinion to learn right now?
Interesting question. I would say Python, JavaScript, SQL, Java, and perhaps PHP.
And can you give me
But I'm talking about from a purely mercenary point of view. If you are looking for work, if you're looking to just start making some money, then these are the languages you are interested in, because these are the biggest, hottest, most popular languages according to many language popularity
Can,
rankings.
can you just walk through what the use cases for each one of them are?
Sure. JavaScript, we mentioned earlier, is a language for programming front-end systems. The pieces, which the parts of your application system which interact with users, so incredibly important. And Python, very useful for backend systems as well as for data science systems, data engineering systems, which is obviously such an incredibly important technology today. SQL is the grandfather or granddaddy of all data engineering and data science languages. It's before you had your Pythons and your other languages, you had SQL, which was the OG.
And there's a lot of legacy systems that still work on SQL.
Many legacy systems, many new systems. SQL has undergone a kind of renaissance in recent years, where it has become the de facto lingua franca of database and data engineering systems and pipelines to talk to each other. Very important to learn. I think one of the most important languages you will learn, whether in your career, whether or not you are a programmer. If you know some SQL, your brain will expand.
And the thing is, there are many people who are not programmers, who are actually managers, who get into a situation where they have to deal with data, and they're told, well, learn SQL. And they end up having to learn SQL because
make a dashboard.
Make a dashboard.
You need to make a dashboard. Well, okay, where do I get the data for the dashboard? Oh, it's in a database. Oh, okay. Yeah, I guess I need to go and figure out how to get the data from this database.
Yeah. And so they don't have formal training, but there's enough material on the internet that you can. That is one of the other things is none of these languages are necessarily hard. They're more syntactic.
Yeah, that's the thing, right? Learning a programming language is not difficult. It's not the learning part that's difficult, I want to emphasize. It's the mastering part that's difficult. It's the Malcolm Gladwell 10,000 hours of repetition to master any field, right? It's similar to that. Or it's like what this character in a Kung Fu TV show once said. How long, he was asked, how long does it take to learn Kung Fu? He says, well, only a lifetime, maybe more.
So we did 3 languages here.
Yes, we touched on 3. So the other one I was going to say is Java. Java is still incredibly important in backend systems and enterprise systems, because it's used by many heavy-duty businesses, commercial enterprises everywhere, in universities everywhere. The other one is PHP. PHP is incredibly popular because it's a simple language that lets you get a lot of stuff done. It drives many e-commerce systems. So if you're interested in e-commerce,
in fact, WordPress, one of the most commonly used CMS, content management e-commerce system, is basically built on PHP. So there's always a demand.
WordPress is built on PHP. Wikipedia is built on PHP. Facebook was originally, and many parts are still built in PHP. Many important systems are built in PHP.
So I'm gonna. So there's, I think, 5 minutes to discuss 2 final topics.
Yeah.
One of them is, and I think this will elucidate on the point that you were talking about, the 10,000 hours that it requires. One of the topics is no-code programming. No-code programming is something that's come up recently. Your thoughts on that? It offers a levels of abstraction, but it also, I think, really speaks to that point about what you're actually doing when you're programming instead of just the syntax. What beyond the syntax you're doing? Because no code, you don't need to learn the syntax anymore. And I think the other similar kind of aspect is the ability of ChatGPT to write really nice lines of code, but they're not in an environment. So you need to still transport them into an environment. So your thoughts on these two points.
I think these are interrelated points, and the basic idea behind these points is uh, uh, to make the really to cut out the middleman, or to try to cut out a lot of the middleman, to automate away the work of building software, which is to a large extent why many people say that there is a scarcity of software engineers in the industry. People can't hire enough software engineers, which is again kind of like ironic considering the fact that we're having mass tech layoffs right now.
Yeah.
Anyway, so the point is, people are trying to automate away these jobs. The same way that they've automated away many jobs in many industries. It's nothing new. This is kind of like the human condition. Anyway, so the point is it viable though? Like my opinion, right? No code, low code. Sure, they might have their place in demos, prototypes, just to kind of proof of concept. But I don't think that they have a solid foothold in productionizing systems that you would actually want to make money from. That you would seriously consider to be safeguarded against security risks, risk of data breaches and hackers and malwares. Right now, at the very least, and I don't see a future where they would, because no matter how powerful language learning models get, and like ChatGPT, they continue to make very basic mistakes that it's true that humans make mistakes as well. Humans are famous for making mistakes, starting from the Garden of Eden, but onwards. But we have the capacity to kind of check each other's mistakes. If you get two language models to check each other, odds are you're not going to be, they're not going to be fixing each other's mistakes. Just that one way to put it. So no code, low code systems, yes, they do have their place. Language models, yes, they have their place. It's not a very large place right now. There is still a need for the skill and mastery of software engineering. Engineering is the key word here.
And that's what I actually wanted to bring out as well, because I think I've played around with both of these things, and to me they help me quite a bit. The place where they help me is accelerating the coding, but it is not production level coding. It is absolutely about being able to take an idea from my head and bring it to real life without production level coding, with you know no code is going to be slower than production level, because there's a level of abstraction that the no code is taken care of. And chat gpt still requires you to be able, you can write the code, but you need to insert it into the right environment. And so it makes my work faster, but it doesn't take away from the fact that I have to still do the engineering piece, the logic piece. So it might make the syntax faster, but it might make the syntax easier, and therefore my work faster, but the performance level is something that you're losing or could be losing, and you need to have that engineering hat, I think. So just reflecting your point. Anyways, I think this covers, in my opinion, a very broad kind of, and I'm thankful to you for giving me this perspective on things, that there's some learnings for me as well in terms of like how software development is done. So thank you very much. I think this covers this episode too. So we'll see you next time.
Thank you, sir. I always enjoy these discussions we have.
Awesome.
Take care. Till next time.
Take care. Bye bye.